Welcome back, everybody. It's your host, Pat Voss, for the Golden Knowledge Podcast here on YouTube, Spotify, and Podbean. I appreciate you for being here with me today. Again, if you want to find me on Twitter, you can find me at Voss Tweets on Twitter, VOSSTWEETS. That is where you can find me. I have a great guest for you today. I know you guys have enjoyed my interviews with Dr. Lawrence Krauss in the past, so this is right along that realm because we do interviews for science, for sports, for politics, and everything in between. So today we have cosmologist Sophia Nasr. How are you?
I'm great. Thanks for having me here.
Thank you for being here. I'm very, very glad that you're able to be on the show today. And there's a few things that I want to touch on today that you actually tweeted out about when you quoted my tweet about the show today. And I wanted to say that I appreciate you for coming on. And you had quoted about talking things about dark matter, black holes. We were going to touch on a few different subjects, and I really appreciate that. The first thing I want to touch on is the Mars Perseverance landing that happened on the 18th of February. What exactly, can we go through that? What does that mean for our exploration of other planets going forward? What does this landing for Perseverance mean?
Yeah, so Perseverance, I think of this rover as like a mission of the future. And the reason why that is that this rover is like the first rover that is carrying an experiment that's going to actually pick up Martian soil and hold it for future astronauts to come and pick up and take back to Earth, or a mission to come and pick up and take back to Earth. And so not only that, we also have an experiment on there that's also going to turn the carbon dioxide in the atmosphere into oxygen for future astronauts to breathe and use as propulsion, because you need oxygen for propulsion. And it's just incredible, like, that we have a mission. Not only is this mission going to look for microbial life in Mars's past, if it ever had microbial life at all, but it's also preparing us and kind of setting the wheels in motion, if you will, for the future of space exploration, which is getting humans to Mars. So it's like, that's why I call it a mission of the future, is because we're getting this ready just for that. And it's like setting the things in motion. It's no longer just an idea or a thought, like it's happening.
Well, that's something that I was very, very interested in is, I know the space program in the 60s, setting foot on the moon and trying to win that space race back then. I also would love to be involved. I don't know how I would be, but I would love to be involved out in some way, shape, or form with NASA or SpaceX to launch something and launch humans to first step foot on Mars, because one of my relatives is actually Gus Grissom, the former astronaut. And I would love to put my mark on something as well for the family if I could. And so for what you were saying is that it's going to be multiple things happening with this rover landing on Mars. What is the future, though, past this rover, past Perseverance? What are we looking for after hopefully putting feet on Mars?
Human feet, then. After we put humans on Mars, what we're looking for? Okay. I think that we definitely probably want to make like a base or something eventually. This is like, we're talking way into the future though, because I want to make this clear, like, just for the mission alone that's taking up soil and holding it for a future mission to come to pick it up, that we expect to happen at earliest in 2031. So getting to Mars is a very big deal, because if we can do that safely, if we can get humans to Mars safely, then that means that we would have figured out how to protect ourselves from the intense radiation that's out there, like the space radiation. And that's the biggest danger of going to Mars, because it's a pretty long flight. Like, you got to wait 7 months to get there, and so you're stuck 7 months in all this radiation, which obviously is not good. And so if we can get humans to Mars, then that would mean that we figured that out, how to protect ourselves from that. And if we've done that, then that opens so many other doorways for us. And so this is a really big deal. It's a really big deal to just getting to Mars just opens the door to other possibilities that you can imagine in space exploration and such within the solar system, because we don't have spacecraft that are capable of reaching beyond the solar system at this moment. But yeah, so this mission is a very big deal for that reason, is because if we can get humans to Mars, then that would mean we figured that out, and that opens the door for a lot of other space exploration, including humans.
One thing I was very excited about with Perseverance was when it landed, when the touchdown was confirmed. I saw you tweeting out, everybody was tweeting out, everybody was, gritting their teeth waiting to see, because after 7 months, anything could go wrong. And I don't think a lot of people that, well, I don't want to say, I'm not going to get into that portion yet, but there were a lot of people gritting their teeth for sure, waiting for those 7 minutes of terror. And can we say, kind of elaborate on that? What does that mean? 7 minutes of terror. What are we describing?
So 7 minutes of terror became named that when we were landing Curiosity. At that time, it was 7 minutes to receive the signal back because of the position, like how far away Mars was from Earth. So we still call it 7 minutes of terror, but this time it's 11 minutes. So Mars is a bit further away from us. And so it takes 11 minutes for a signal to come. So technically it was the 11 minutes of terror. But what the 7 minutes of terror really refers to is that there's going to be a period of time where we actually have no idea what's going on. And the rover has it's already landed. So if there's an accident, or if it didn't work out, or like, a terrible crash landing or whatever, or a successful one, we don't know until that time is up. And that's why they call it the 7 minutes of terror.
That has to be. And I remember listening to NASA's stream of this and listening to the gentleman that was on the side commentating while they were waiting for this to land, or to get confirmation that it successfully landed. And the breathing, hearing this man breathe and how nervous he was. I can't imagine doing that for a career, having to stake everything that you're putting forward, every bit of science, every bit of, mathematics, the engineering behind how to get the rover onto Mars, and to stake all that on, let's figure out if it all worked. That's has to be nerve-wracking.
Yeah, oh goodness. I mean, I can't imagine what it feels like for the people that work on it when they're waiting during this 7, or in this case, 11 minutes of terror. But then imagine what it feels like to be successful. It might make it all worth it, like, in my opinion, I feel like that makes it all worth it. Because it's like, even if a mission goes wrong, we will still learn things from it that we can take and use for future missions and things like that. And so no mission is a failure. No mission is a true failure, because we'll always learn things from these missions, regardless of whether they're successful or, there's a problem in between or whatever. So we'll always learn things. And so, I mean, I think that just the possibility that things will work out just makes it all worth it for anybody working on that.
So speaking of making it worth it, what makes what you do worth it for you to keep on the path that you're on in studying and learning what you're learning?
Oh, for me, it's really just the search for more knowledge. It's uncovering the mysteries that we don't understand. And so it's like, to be a part of trying to answer one of the biggest questions the universe has to offer us, to be a part of that, whether like we actually get there in my time or not, and I think we will, hopefully. It's a thrill to be a part of working on uncovering this, so that we can learn what's beneath all that, because we have no idea what it is. And so for me, it's the excitement of the possibility of kind of like, learning that in my lifetime.
One thing, and this is before we move on, because I did want to ask you about black holes, and I wanted to talk about dark matter as well to close out the show. But what I wanted to ask about a direct question about like moon landing deniers and people that like flat earthers, things like that, conspiracy theories. I wonder, because I've asked Dr. Krauss the same question, and I just wonder what you think, or what your takeaway is from people that actually think that the moon landing was faked, and that maybe, you know, the Earth is flat, the government's lying to us. Where does all of this in your mind come from? Where does that come from, and why does it exist to this day, do you feel?
Ooh, yeah, it's a pretty loaded question. I think part of it comes from a lack of trust in scientists. Part of it comes from a lack of trust in scientists. And so when you don't trust the source from which you're getting specific information from, you will always have doubts towards that. And I feel like it's kind of compounded in that. And so it becomes more of like a culture, maybe, you know, like that, you know, once you're like on that side, you just got to keep going. Because I mean, look, NASA sends us images all the time, video, keeps us up to date. We can even go and get access to any of the pictures and stuff like that. Like, for example, I used to process images from the Cassini spacecraft. So that's a spacecraft that was orbiting Saturn, and now it's a part of Saturn. Now we sent it into Saturn so that, well, not we, because I wasn't on the mission, but they NASA sent it into Saturn to prevent it from hitting the moon Enceladus, just in case, because you don't want to contaminate a possibly habitable moon. And so that data is available for anybody to download. I just went on there and downloaded it. You can do it now too. And you could do that with the Mars data as well. And so having involved the public this much in that kind of tells me that it's more than just a disbelief. It's more than just a disbelief. I feel like it's a culture, and the one way that we can work towards breaking it is maybe building up the trust in scientists.
That would be nice. I mean, I don't know why there wouldn't be. I understand from past history of certain scientific discoveries, and I put that in air quotes, because of you know, to try to science that was supposedly saying that certain human beings were less than other human beings, and there's other things like that. So you do have culturally people that are of certain cultures that would say, well, we don't trust science because look what it's done to us, or look what it used to do to our culture. I can understand that to a degree, but then I look at people like, you know, Dr. Neil deGrasse Tyson, who obviously is not, he's not held back by that mindset, I would feel, to the point that he is an astrophysicist. And I don't think that, I think that once we learn how to cope with past traumas, or whatever would go into, whatever variables go into us being non-believers in science, or whatever it is, I think that knowledge eventually, or it sprouts into knowledge eventually. And I'm hoping that that's a community and a world that we can see in the future, where the majority, and I do mean the vast majority of people, understand that science is real, no matter what we want to believe, personally.
Mm-hmm. Well, I do want to point something out. I don't know if there are, like, you know, demographics on like, I guess, the people who are disbelieving. I don't know that there are. And so I don't think that answers the question, because a lot of the people who are, you know, who don't believe in science are in fact on the same team as the people who would make the science where they try to, I guess, like eugenics, for example, which is what you were talking about. I mean, you know, a lot of the people who don't believe in it are white too, and so I don't think that's the answer that's maybe part of this. I don't know. I think it's more, perhaps maybe that's a part of it as well, because that is pretty. It's pretty. I guess really uncomfortable to know that there was somebody in science who would abuse it and do that. And so I feel like anybody could take that. Like, doesn't matter what demographic you are. Like, even me, I look at that, I'm like, you know, Like what is that? And like, it's just, yeah, I think it just goes way deeper than that. I really think that the public just has, for some reason, politicizing things is one issue, uh, and then that creates almost an automatic mistrust in scientists. I don't know, because of the fact that, like, you know, politics are involved, and that's, I feel, one of the things that's driving us downward, like, a lot, is politicizing things that really shouldn't be.
Well, and I hope that eventually that does or is able to be corrected so that it's not, you know, informing so much mistrust in the wide, you know, varying communities around the world. Because to me, for someone who, and this is just quick before we get on to black holes, for me, who grew up as a believer and and now I consider myself an atheist, I jumped. And beforehand, when I was still a believer, I thought that there was plenty wrong with science and evolution was a lie. And there was so many things that I was told. And then I started really doing research and figured out that how wrong I can be. So that to me was fulfilling, though, in the end. And now that I'm in my early 30s, it's fulfilling to me to know that there are some things that we can absolutely get wrong. And that is why I like science, because it does have that self-correcting mechanism. It does have the ability to do so, and not many other things have that ability.
Yeah, right, exactly. And so I feel like um we need to somehow get people to open up their minds to the possibility of themselves being wrong, because that's probably what you did in order to get to where you did. And so, you know, and mind you, that's not, that has nothing to do with atheism or religion. Like, you might go the other way around too. You might be an atheist, and then your truth in that case would be that religion is right for you. But in this case, we're talking about literally, like, this is science, and so these are facts that are still kind of, I guess, tainted with culture. You know, it's tainted culturally because science is done by human beings, and so you can't really disentangle that. But just getting people to, I guess, just kind of like be open to the possibility of being wrong would open the door for us to be able to build up that trust again.
So dealing with possibilities of being wrong or possibilities of certain misunderstandings, since we now want to talk about black holes, what is a fundamental misunderstanding that you see in a non-science community that they fundamentally misunderstand about what black holes are or how they function?
Yeah, so one of the biggest ones is that black holes suck. They don't. And I don't mean in that they are cool. So that's not the kind I mean. It's like people tend to think that, you know, if you put a black hole somewhere, then all of a sudden it's just like sucking in everything around it and everything's gonna go in. But here's the thing: if you were to take the sun and just replace it with a black hole of the same mass, nothing would happen to the planets at all. We would just continue to orbit, except we would, of course, freeze eventually. It would take 8 minutes for us to realize that there's no sun anymore, and so there's no more energy, and so we would eventually freeze. But, like, in terms of our motion, nothing would change. So that's the biggest misconception I feel around black holes, is that they tend to suck in everything, which they don't. It's actually really hard to, like, aim at a black hole and get something to fall into it.
There is, with a black hole, though, a possible theory, or at least a hypothesis that I've heard about the beginnings of this visible universe. And I do say visible because, of course, at this point, we don't actually know how things started or if this is actually the absolute start. You know, we don't know that yet. So the hypothesis that I've heard is that because scientists know, and correct me if I'm wrong, that black holes can, in fact, emit particles. If that is how possibly the quote unquote Big Bang started, was a particle or a singularity emitted out of a black hole, and that is what may be part of a larger universe that we cannot see as of yet.
I have not heard that. What I have, I've heard other ideas though, where our universe could be inside of a black hole or something like that. I've heard things like that, but yeah, I'm not like in terms of the universe becoming because of a particle that that a black hole emits. I'm not too like I'm totally not familiar with that at all. So
Well, I do apologize. I may have gotten that incorrect. But one thing that I wanted to ask then, on top of what I was saying, is asking, what are some possibilities that we see as, certain theories of how our observable universe began? How do we go back and make a distinction?
okay. So the first thing that I do want to mention is, so in terms of like the observable universe, we'll never see anything beyond that. So it's not that, that we haven't gotten there. We just never can. Like physically, the observable universe that's our limit. So there's like, even if the universe is infinite, it's completely, we don't have any access to it at all. So there's a huge chunk of the universe that we'll never have access to, which just the idea of that blows my mind as well. But so because going to the Big Bang is pretty impossible right now. And so, because when you try to extrapolate backwards in time, what happens is that kind of the laws of physics tend to break down. Like you can't go too far back because we only understand things down to the Planck size. And so when you try to extrapolate further back than that, you can't. Like the physics just doesn't make sense. And the one thing that might be able to resolve that is if we can unite the theory of gravity with quantum mechanics. And the reason why that is because the universe is macroscopic. It's really big. Whereas if it began from a singularity, that would have been very small. And mind you, really, I also want to mention that singularities are actually kind of things that come out because like the math breaks down. So we don't understand it further. So that's what really a singularity is. And so that's kind of why we can't really go backwards in time, because we can't go further back than the Planck era with or at least a Planck length. Like this is like in physics, the limit of how small you can go is a Planck length, a Planck mass, Planck this. So anything smaller than that, physics can't. Physics just doesn't work. Okay, and that's with our current understanding. And so some ideas that have come up, you've probably heard about, like the multiverse. And so that's like one of the ideas, saying that, well, in the same way that we weren't the center of the earth, we weren't the only galaxy. We discovered that in 1930, by the way. So it's not that long ago that our universe became what it is, with billions of galaxies in our mind. And so this kind of takes it further and says, but it's more intricate than that. Like, it comes from many different types of theories and such. But it just says that essentially our universe is just one of infinitely many. So it just kind of popped into being. And there's like, it's in a field, like, so this quantum fluctuation kind of gave rise to our universe. And so that would kind of explain it in a sense that, oh, okay, we're a part of a multiverse, and so that's what happened. Problem with that is it's not exactly testable, right? We can't reach another universe. Like, we can never do that. And so we could look for signs in our universe, for example, if there was like a collision, or if we somehow were to be able to discover extra dimensions and things like that. These are things that would indicate that multiverse theory might actually be correct. And so that's where we are with that. That's why we can't really go far. We can't go far enough back in time to be able to understand exactly what happened at the Big Bang.
So I'm wondering not what would unify that. That's not the question I want to ask.
If I knew that, I think I'd have the Nobel Prize already.
Correct, which is why I try to correct myself as quickly as I could. What I mean is, once you know, we have technology or we have some kind of mathematics that does not break down, that can very likely. And then the thing is, I'm not pessimistic in this realm. I don't think that I mean, with the history of modern science and the way that technology has formed and that we've made strides like we have, I don't think that it would make any sense to think that it would never, like I've heard some people say, science will never know this. And it kind of makes my blood boil a little bit, because it's like, that's presuming that, and that's not exactly how this works. So I'm wondering, is there a possibility, at least, for if a single point is not the answer and it's part of a bigger universe in which we are not, it's not just everything. Our observable universe is not everything, right? If that turns out, do you think, and I'm sure you know what I mean when I say God of the gaps argument, meaning that putting God in where we don't have understanding at the moment. I'm wondering how we see that going with communities here on Earth, if that does happen and it's not the definite beginning of everything, where they can no longer put, hey, God, poof this into existence. I'm wondering what happens then. And I'm only curious in asking this because I've spent the last 3 days getting bombarded with this question nonstop from other people. So I figured I would ask just as an opinion.
So wait, just to be clear, the question is, what happens with them? Like, I mean, I don't really know. I mean, I suppose one could say that God created the multiverse too, though, so it's like, so I don't think that the God argument is one that you can ever eliminate. I don't think it's something that we really necessarily want to do. Like, if people, I feel like belief in God makes people comfortable. It also like makes it's something some people need, and they thrive off of that, and I think that's good. But in science, we need to look further than that, because in science we can't just say, okay, well, if God did this, so we're good. That's not how we got technology. Right? That's just not how we got here. And so, that being said, I also want to be clear, like, science and religion don't necessarily not mix. Like, they could totally mix. I feel like religion is just a personal belief that, that anybody can have. You can either be religious or you can be atheist. It doesn't matter. And you can still believe in science. So I guess my response to that would be that I don't think it's necessary for us to work on that, on I guess, somehow, I guess, preventing people from what is it, the God argument? What did you call it again?
Oh, the God of the gaps, meaning that they just put God where they don't understand, when there's lack of understanding at the moment.
Right. Yeah. So the God of the gaps. I mean, like, I think that's so it's okay to do that if it works for people, among themselves. It's just that we just need science to continue doing things and looking for more, and not, just say, oh, well, and it would never do that, because, like, okay, well, God must have created it, so we're all good now. No, that's not how we progress. And I like, I feel like faith is definitely very personal, and so it should be sort of disentangled from it, if that makes sense.
No, it absolutely does. And I'm sorry I went on a little bit of a tangent there. I apologize. I try my hardest not to do that in my podcast.
Oh, that's okay. I know how that is.
I wonder, with what you said earlier, in relation to what you said earlier of, we don't know, or we can't see beyond our observable universe because of the limits of things break down, and we don't know, there's no way to see that yet, or to even grasp that yet. But I would say is one of the reasons why we cannot see it, or things break down, does it have anything to do with expansion in our current universe through the means of what we call dark matter or dark energy? What do we is there a connection? And if so, yes. Or if, okay, so that answers that. I was saying, is there a connection, and why is there a connection? Why does there seem to be a connection?
Yeah. So, okay. So, but I want to make this clear. So, like, the observable universe is something that does change with time. So the expansion of the universe continually will pull things out of our observable universe because they move faster than light. So the things that are moving faster than the speed of light, eventually it's not going to have enough time for the light to reach us. And so those things, and then, in the future, for example, some of the galaxies that we can see, future inhabitants of Earth or another planet, because we're talking about, it has to be enough time. And, on the cosmic scale, it has to be like more than, 100 years, for example. But yes, so future civilizations who look at the sky will not see galaxies that we can see today, because those will have receded out of their observable universe. There's another sort of a horizon, which we call like a particle horizon. This is one that like this is a limit that it doesn't matter when, like at any point, you will just never be able to like, I guess you'll never be able to go beyond that. So you'll never be able to communicate with anything beyond that particle horizon, whereas the observable universe like will change with time.
My question, and I forgot my mic was on mute. My question was, it's kind of stems from what Dr. Tyson has said when he was interviewed by Stephen Colbert, and he said that, listen, the observable universe that we see now, like you said, is ever changing, and it is expanding at a faster rate. Things that are twice as far away expanding at a rate twice as fast, and so on and so forth. And the one thing that he brought up that does mess with me quite a bit, that even aggravates me, is that he said, the thing that keeps him up at night is, was there a piece of the universe that we don't see now that we're not even sure that we're touching the elephant and there's even an elephant there, so to speak? Like what if we're looking at the shadow of the elephant and the elephant was moved? And he just, putting it in that term, I'm just wondering, I'm wondering, there has to be, unless we talk about interplanetary travel or some way to using some kind of wormhole, sci-fi-ish, what have you in the future, if that comes along. Without that, I think there is definitely, at least in this observable universe of ours, a cap on our knowledge to be gained. Is that not correct?
Yeah, and I can actually explain why in this way. Because the speed of light is finite, so it has a specific speed. Like it's it's, I guess, let me give it to you in kilometers per second. It's 300,000 kilometers per second. I think that's something like 300,000 miles. Oh, sorry, excuse me, no, 300,000 kilometers per second. So I think that's something like 1.7-ish miles per second. I'm not, or 170,000 miles per second. I learned all this stuff in SI units. That's what we talk. So so I don't really know it in miles, but that's probably going to be somewhere around what it is.
That's okay. We need to convert anyway. Go ahead.
Yeah, I would say so. But the fact that we have a limit on the speed of light, anytime that we look out into the universe, like for example, Andromeda, when we say that Andromeda is 2.5 million light years away from us, that's saying that it takes light 2.5 million years to travel to us. And so anytime that you look at Andromeda, you're only ever going to see it as it was 2.5 million years ago. And so that's true for a galaxy that's 1 billion light years away from us. That's true for a galaxy that is 1 million light years away from us, as we just, like for example, Andromeda. And if we were to discover, for example, wormholes, or if we were to like figure out how to really keep them stabilize them, so how to create them and then how to keep them stable so that we can actually make use of them to travel in space-time, because that's a big problem, is that they're actually not stable. And so if you create a wormhole, you're not done there, because if you travel through that and it collapses on you, you're gone, And so if we do figure that out in the future, then we would be able to go to a place like, say, Andromeda, in which case everything now looks different, because now we see the Milky Way not as it is today, our own galaxy. We're going to see it as it was 2.5 million years ago. And so by being able to move in space, we can see things differently. And therefore, like if we were to be able to, go to a galaxy that's 1 billion light years away, for example, by some wormhole, then we would see a completely different universe, because we would see kind of like, well, it would be the same. It would be the same universe, but everything that we've seen before, like for example, the Andromeda galaxy is going to look different. Milky Way is going to look different. Like these things, they'll look different to us because of that, because it takes that time for the light to get to us. And so that would definitely open a slew of doors for us in terms of like understanding things. Like for example, that would directly give us a way to look at how galaxies evolve, because we can't do that without simulations today because of how things, you know, like cosmic time is like, you know, in the millions of years or and so if we were able to do that, then we could see what a galaxy looked like at some point, and then look at that same galaxy and see what it looked like at that time. And that would allow us to actually create a real picture of what galaxies actually evolve like. And so, yeah, that would definitely open up a lot of doors. Like to me, yeah, it's like the finite speed of light is kind of like, it's almost, it's a twofold thing. It's great because that means that you're always looking into the past. You're always looking into history. But at the same time, we can never know what anything looks like right now. So it's limiting, but it's also beautiful in its own way.
Well, and that's the interesting part. That's what entertains me, is looking into history, as you said. But this is the other thing, that when I've talked to other people about when I've talked to other people about whether or not we're alone in this universe, you know, and I just wonder, because we're looking at things as they were millions or billions of years ago, I'm wondering if that in any way mathematically shores up our chances of being realistically one of the only, because we're looking at the past. And we don't know if the civilizations even exist on these other places anymore, if they did. And so if they don't any longer, that does it mathematically do anything for us? Or is it still like is there life out there 50-50, or is there life out there, you know, maybe 80-20 based on microbial life even?
Yeah, I think it doesn't change anything with regards to that. It changes the fact that, for example, the only thing that I guess the speed of light does, the fact that it's also a limit, is well, it makes it really hard for us to go different places. That's, well, I mean, it's not really the speed of light. That's actually technology in general right now. Because if we were to move at the speed of light, time would not move for us. So if we could be able to do that, then that would also be like a solution to all the problems, which we can't because light is massless. But I got lost where I was. We were talking.
We're talking about possibility of life elsewhere.
Yeah, right. And so if there is life elsewhere, it's still going to be there. And there's no technology that would allow us to be able to see it. So like the things that we can see, like it's just the way it is. Like you can never create a telescope that is going to be big enough for us to be able to pick up, you know, a life on a planet. But we can do things like look for signatures, like, you know, look for specific chemicals or specific types of elements in the atmosphere, if it has an atmosphere, which we need for habitability. And so, yeah, I think that just remains what it is. It's an open question in a giant universe with uncountable galaxies and therefore planets as well that orbit stars, in the right place too, in the right place, like the habitable zone. It's really hard for me to, it would be really hard for me to just accept that we're the only life here, because there's just so much, there's so many other planets and so many other possibilities for it to evolve somewhere. Whether we can get to it in time or not, that's a different story. Like, for example, okay, this is so even if we're looking at like a planet that's further away from us, let's say 300 light years away, we would be seeing the signatures as they were 300 years ago. And so that's maybe one thing that would, for example, hinder us. It wouldn't change like what happens with life, but it would hinder or maybe sort of affect our ability to discover life in that way on another planet, because let's say that we were just looking at the ends of it and then it just went extinct, or we're looking at it a little bit too early. It's actually there today, but it didn't, it didn't evolve or form until I don't know, let's say 1,000 years later, if we're looking at something that's like 1,000 light years away or more than that, which you can, because we live in a galaxy that's 100,000 light years across. And so, yeah, that's I guess that's the limitation that I would see. But yeah, I don't think it does anything to the actual possibilities of there being life elsewhere.
And lastly, so that I don't go on about 3 more tangents because I feel them coming. My final question to you before we wrap up for today is, what with cosmology, what is something before, in your lifetime, what is something in your lifetime that you would like to discover, something that you'd like an answer to, which science is searching for currently, that you would like to have an answer to before your lifetime is over?
What is dark matter? Instantly. That's it. That's what I want to know. What is dark matter? That's what I want to know. This is stuff that's everywhere. It's invisible. It's passing through you right now and passing through me right now. I can't feel it. We can't see it because it doesn't interact with light, but we know it's there because it interacts with gravity. And it's like, I want to know what it is. So that's what I want to know within my lifetime.
And actually that spurs on one last question then. Are there experiments currently going on to test to see if there's dark matter interacting and how to test those interactions? Is there something happening that we're doing right now to test those?
So actually, okay, so interacting dark matter is a different model than the sort of, I guess, the standard paradigm of dark matter, which is that it doesn't interact at all. Which we're seeing, it looks like, there's problems with it, like a lot of problems with it. Well, it's not a lot of problems because it actually describes the universe. It's the most successful at describing the universe on large scales, but when you start to zoom in, we start to see problems. And so dark matter that will experience interactions or interact with other dark matter particles. A professor who's at my school, he is a part of a team that has created an experiment that's at CERN now. It's called Phaser. If you watch Big Bang Theory, you'll probably have seen it on there, even if you don't know, because his work was actually showcased on it. And that's actually it's already working right now. So that's one that is testing interacting dark matter. So what it's doing is looking for the particle that would mediate those interactions rather than the dark matter itself. And mind you, like when I say it's looking for that, it's really looking for, like, if such a particle were to come out, then that particle would create other particles. And so like every search for a particle is kind of indirect. Like when we found the Higgs boson, we didn't find the Higgs boson, and it was like, okay, here it is. No, we found signs that are like, definitely this has to be the Higgs boson because that's the only thing that would do this, for example. And so that's how we find it. But yes, so there's an experiment that's doing that now. There are experiments that are looking for the interact or the non-interacting dark matter, so cold collisionless dark matter, if you will. And those haven't found anything yet. So hopefully something like Phaser or another experiment that starts to test dark matter that does interact will maybe find it soon. And in order to do that, we need to learn more about the particle properties so that we know where to look. And that's part of what I'm doing.
Very, very nice. And Sophia, thank you so much for coming on the show today. I appreciate you putting some knowledge out there for people that are watching and loyal viewers and listeners of mine. I appreciate it very, very much.
And thank you so much for having me.
No problem. And where can they reach you? Where can people reach you on social media if they want to follow you on social media?
Yeah, I'm at Astro Particle everywhere. So it's like Astro Particle. So rather than particle, you replace the CLE with girl. I'm Astro Particle on Instagram, Twitter, Facebook, TikTok. I have a website, astroparticle.com, where you can even, reach me there if you wanted to like shoot me an email or something, you can contact me through that website as well. And yeah, those are the places that you can find me right now.
I appreciate that. Thank you so much for coming on the show, and you have a good rest of your evening.
And you as well.
Thank you. I'm your host, Pat Voss, for the Golden Knowledge Podcast here on YouTube, Spotify, and Podbean. We had cosmologist, astroparticle physicist as well, Sophia Nasr. Thank you so much, and we'll see you guys for the next episode.